This example is just like the one in the previous video where we're given a trig function. It tells us where that angle is on the coordinate plane and tells us to use basic identities and the signs of the trig functions in each quadrant to find each value. It's giving us sine of 4 pi plus t, and it wants us to tell what is this value given this information. In our last video we had located this in the coordinate plane. If I make a small drawing here, t is in this quadrant, in the third quadrant. This is where t is. So that means that my cosine will be negative, my sine will be negative, and my tangent will be positive. That's what that means. So when I find this sine, I know I have to have a negative value. And the cosine that they give us is negative, okay, as it should be because it's in the third quadrant. Also here to the side I have my periodicity identities, and there are 3. I'm going to use this to try and solve this problem. Okay, let's start. It says sine of 4 pi plus t. Notice this looks a lot like this. It says t plus minus 2 pi. Since I have a plus, this is very simple to rearrange so that it looks more like what the identity says. Right? By the commutative property of addition, I can say 4 pi plus t, or I can say t plus 4 pi. It's the same thing. Okay? So now that I've rearranged the order of this angle, I can compare it to this property or to this identity. It says that if I have t and I add or subtract 2 pi, and remember it can be 2 pi, 4 pi, 6 pi, 8, 10, any even number of pi, that will equal sine of t. And I'm going to show you why that's true. If this is t here, and I go around from t, if I go around one whole turn, I end up at the same angle I started on. If I go around twice, here's one turn, 2 turns, which is 4 pi, I end up at the same place. So if I go around 3 turns, 2 pi, 4 pi, 6 pi, I end up at the same place. So that's why the sine of t plus 4 pi is going to equal the sine of the original angle, because it ends up at the same place. It's a coterminal angle. Okay? So I've simplified this to this by using the identity, and I've shown you why this works. Okay, so what is sine of t? I don't know what sine of t is. I have to look for it. I have enough information to look for it, and I can use basic identities, and the one I'm going to use here is cosine squared of t plus sine squared of t equal to 1. I'm going to substitute the value given for cosine, and I'm going to solve for sine just like we did in the previous video. This becomes 4 out of 25 plus sine squared of t equal 1. Now I'm going to subtract 4 over 25 on both sides. I'm going to continue here, and I have that the sine squared of t is equal to 1 minus 4 over 25. I look for common denominators, and this is 25 over 25, that's 1, minus 4 over 25, which is going to equal 21 over 25. Now the sine squared of t is equal to 21 over 25. I have to square root this, and when I take the square root, this becomes plus minus. Now I have to decide if I'm going to choose the positive or the negative, and what helps us decide is this information that they give us on where t is located. And we had said in the beginning that t was located in the third quadrant, and in the third quadrant sine would have to be negative. So I have to choose my sine of t as negative square root of 21 over 5. And this 5 comes from the square root of 25. And there you have it. Sine of 4 pi plus t is equal to negative square root of 21 over 5. And there's your final answer. Go back and try this on your own. And if you have questions on any other problems that you encounter on your homework or just practicing from your book, you can ask. You can send me an email and I'll try to answer or help you with the problem, okay? Okay, I hope you understood, and I'll see you next time.